Let us now see the computation of altitude of the moon. What is the cause of moon being different from other bodies? And how do we follow this method? Let's first see what is the information which is provided to us in these questions. So we will have the date given to us, available to us. Then we will have the index error of the sextant, and we will have the height of eye of the observer. Uh, Time is usually not given in these questions. In Marpass questions, whether it is sun, star, planet, or moon, time is usually not provided here because we can obtain the time from the almanac. Now we have the DR position also available to us. The DR position is given. And what is required as usual is the sextant meridian altitude of the moon. So let us see the method now. First of all, we find out the GMT of the meridian passage. So we obtain the GMT meridian passage of the moon. And once the GMT Marpass is obtained, we find the declination of the moon from the almanac. Now, if it was a normal Marpass observation of the moon, let us see what we used to do in a meridian passage calculation. In a meridian passage calculation, we were given the sextant meridian altitude of the moon. We applied the index error and the dip correction basis the height of eye of the observer, and we obtained the apparent altitude. Now to this apparent altitude, we apply the total correction. Now in case of moon, the total correction is divided into two parts. You have the main correction given at the top of the table, and you obtain a certain altitude after applying the main correction. And then you apply the second correction, which is known as HP correction, horizontal parallax correction. So once you apply these two, if required, if it is an upper limb observation, you apply the upper limb correction also, which is minus 30 minutes. Once these corrections are applied, we get the true altitude of the moon. So 90 minus this true altitude gives us the MZD. We combine this MZD with the declination of the moon, and combining these two, we get the observed latitude of the moon. So this was the normal procedure which we followed when we solved a meridian passage observation of the moon. Now for computing the altitude of the moon, we follow the exact method, same method in reverse. So we will be starting off from the bottom, that is from the observed latitude, moving upwards, going up to the sextant meridian altitude of the moon, exactly as we did in sun, star, and planets. So let us show it with a upward arrow. The arrow indicates that we will be starting at the bottom and proceeding upwards till the top, getting the sextant meridian altitude in the end. So we start from the observed latitude, and in place of observed lat, we use the DR latitude, which is given to us in the question itself. So DR latitude is combined with the declination. We have already obtained the declination from the almanac. So declination and the latitude are combined to get the MZD. Once we get the MZD of the body, 90 minus MZD gives us the true altitude. So from the true altitude, in case a upper limb correction is required, if they have asked us to calculate or compute the altitude of the upper limb of the moon, we will apply the upper limb correction, which is minus 30 minutes. Going upwards, we will write it as minus 30, but going upwards, we will apply it as plus 30. So after applying the upper limb correction, we now apply the HP correction. HP correction is obtained from the bottom of the table, which is entered with the horizontal parallax of the moon. We have the time available to us. We can get the HP of the moon from the almanac, and we can obtain the HP correction. Now, once the HP correction is obtained, we will get some value here. You can call it a uncorrected altitude. Now, the next thing which we need to obtain is the main correction. Here is where the problem comes. Here is the difference. Now, the main correction table of the moon changes very fast. What I mean to say is that with a slight change in the apparent altitude, the main correction of the moon also changes. So normally the main correction table is entered with apparent altitude, but we do not have the apparent altitude at the moment. What we have is the uncorrected altitude represented by this box. We have the uncorrected altitude available with us. So the problem now is that if we enter into the main correction table with this uncorrected altitude, the main correction which we will be getting will have error in it. Why there is a error in moon? There was no error in case of sun, star and planet. The reason for that is in case of sun, star and planet, the value of total correction changes very slowly. For a big range of apparent altitude, the total correction is almost same. Whereas in the case of moon, it is not so. With a slight change in the apparent altitude also, the main correction of the moon changes. So we cannot use the uncorrected altitude to enter into the main correction table. So what do we do here? Now pay attention, pay little attention. People find sometime this step difficult to understand. So in a minute, we will be able to understand how we have obtained the main correction. We have an uncorrected altitude available to us. We enter into the main correction table with this uncorrected altitude. Now, when you get the main correction will not be accurate. It will not be exact. It will have error in it. We can call it approximate main correction. So when you enter into the table using the uncorrected altitude, you get the approximate main correction. Why is it approximate? Because we did not enter the table with the apparent altitude. Apparent altitude was not known to us. What was known to us was this uncorrected altitude. So that is why this main correction is approximate. But nevertheless, we have a approximate main correction available with us now. We apply this approximate main correction to the uncorrected altitude. Okay, in the reverse way. So we apply this main correction, approximate main correction to the uncorrected altitude. Once you apply it, you will get approximate apparent altitude. So we have applied the main correction in reverse. We have got the apparent altitude. But since this main correction was approximate, the apparent altitude obtained will also be approximate. So we have now obtained the approximate apparent altitude of the moon. Now, once you obtain this approximate apparent altitude, we enter into the main correction table again. And now we enter with this approximate apparent altitude which we have obtained now. So using this approximate apparent altitude, we enter into the main correction table and we get a accurate main correction. Once this accurate main correction is obtained, now we can forget about the approximate main correction and the approximate apparent altitude. We can forget about these values. The exact main correction is available to us now. So to this uncorrected altitude, you apply the accurate main correction in the reverse direction, and you get the apparent altitude of the moon. So I'm repeating once again. We started off with the observed lat. We applied or combined it with declination to get the MZD. 90 minus MZD gives us the true altitude. We applied the upper limb correction in reverse if it is required. In case of lower limb, this will not be needed. Then we apply the HP correction from the bottom part of the table, and we get a uncorrected altitude. Now with this uncorrected altitude, we enter into the main correction table and we get the approximate main correction. We apply this approximate main correction to the uncorrected altitude in the reverse way, and we get approximate apparent altitude. We enter into the main correction table again, now with approximate apparent altitude, and we get the accurate main correction. The accurate main correction is now used with this uncorrected altitude to obtain the apparent altitude.
Beta, any doubts up to here? Did you understand this procedure?
इसका कुछ क्वेश्चन है सर?
Okay, we can do a question, beta. I'll give you a question. So theoretically, any doubt coming to the mind? Okay.
No sir.
All right. ठीक है beta. Let's complete it and then we move on to a question.
Once the apparent altitude is obtained, the remaining method is simple as sun, star and planet. You apply the dip correction in reverse, you apply the index error in reverse, and you get the sextant meridian altitude of the moon. Now this process which we have done here is known as iteration. It's a mathematical procedure in which we enter into a formula or a table with a wrong value, we get a more accurate value, and then we enter into the table once again to get the exact value which we require. This is known as iteration. So we have used iteration here to obtain the main correction of the moon. So this completes the computation of altitude of the moon.
Okay, so moving on to the longitude correction. We know that the times of rising, setting and meridian passage of the moon, they are listed in the nautical almanac. Now the times which are listed in the almanac are actually GMT of the moonrise or moonset or meridian passage of the moon at the Greenwich meridian. If we are on any other meridian other than Greenwich, then this time has to be corrected for the longitude of the observer. This is what we call as longitude correction. It is based on the longitude of the observer. Now the doubt which arises in the mind, why we have this extra correction for the moon? We did not apply this extra correction for the sun. Now this correction is required because the moon phenomena, which is moonrise, moonset or meridian passage of moon, they occur about 51 minutes late every day. For example, if the moon has risen, let us say at morning 5 o'clock, then tomorrow the moon rising will be about 51 minutes late. The moon will be rising at about 5:51. This does not happen with the sun. The sun rises almost at the same time on the next day. If the sun has risen at 6 o'clock today morning, tomorrow it will again be at 6 o'clock. The maximum difference for sun can be 1 minute. But in the case of moon, this difference is about 51 minutes. It is also called as daily retardation of the moon. Now, in case of the sun, the phenomena occurs almost at the same time on the next day. You can see this in the almanac also. If you go to any particular page of the almanac, say for example, I have picked up this data. Now, on the 7th day, the Marpas time of the sun is 12:11. On 8th, the Marpas time is again 12:11, and on 9th, it is 12:10. Maximum 1 minute of difference. Whereas now if you go to the moon, the Marpas time of moon on 7th is 10:43. On 8th, it is 11:38. And on 9th, it is 12:34. So the moon phenomena occur about 51 minutes late every day. This 51 minutes is not constant. It keeps on changing. Depending upon the position of the moon and its orbit, it keeps on changing. So clear up to here, beta? Any doubt up to here?
Sir, last slide दिखा दोगे please?
Okay. Here, beta, last slide.
ठीक है sir, thank you.
Okay. हाँ, next out, beta.
सर ये लिखा है ना मेरिडियन पासेज ऑफ द मून अपर और लोअर, इसका क्या मतलब है?
Can you repeat, beta?
सर ये मेरिडियन पासेज ऑफ द मून को लिखा हुआ है, टाइमिंग दी है, दो दी है, एक दिया अपर, एक दिया लोअर.
Okay. So, beta, can anyone tell what is this upper and lower?
Sir, when moon is behind us, sir, inferior meridian.
Very good. So this upper and lower, beta, means upper Marpas is the meridian passage of the moon on our meridian. Lower Marpas is the Marpas of the moon on our inferior meridian. So that is why these two times are given here for the moon. For the sun, it is only given for the observer meridian. For the moon, they have given it for observer meridian as well as his inferior meridian. And the inferior meridian Marpas is also called as lower Marpas.
तो उसका कोई यूज है क्या, ये लोअर में मतलब मेरिडियन का, मतलब अपन बैठे इंडिया में, अमेरिका में हो रहा है, मतलब ये तो कुछ मतलब अपने कुछ यूज का है सर ये?
ओके बेटा, ये यूज में आ सकता है एक कंडीशन में, अगर किसी ऑब्जर्वर के लिए मून सर्कमपोलर हो जाए. ओके, so if the moon is circumpolar, then the observer can take the meridian passage site at both these times, because he will be able to see the moon during his normal Marpas, and he will also be able to see the moon during its Marpas on the inferior meridian. So then this time is used, otherwise not required. Okay. और कोई डाउट बेटा अभी तक?
सर ये मून सर ये हाईएस्ट इसका डिग्री से कितना जाता है, हाईएस्ट डिक्लिनेशन मून का?
Right. Anybody has an idea बेटा, maximum declination of moon? कौन बनेगा नेविगेटर?
23.5 के आसपास ही है सर.
54 degrees.
How much? Second guess.
So 23 degrees north and 23 degrees south ऐसे जाता रहता है.
Okay, 23 north to 23 south. So maximum is 23. Any other option?
23 degree 27 minute.
23, 27. Okay.
28.5 तो नहीं सर?
Ankush remembers it. Beta, it goes up to about 28 and a half to 29. Okay.
Yes, sir.
The maximum declination of the moon is about 5 degrees above the maximum declination of the sun. Sun is at 23 degrees 26.7 minutes maximum declination. So moon is about 28.5 maximum declination.
Okay.
Okay. और बेटा और कोई डाउट?
सर ये मून मेरिडियन पैसेज अपर एंड लोअर फिर से एक्सप्लेन कर सकते हो प्लीज?
ओके बेटा, I will explain this to you in detail when we do the circumpolar bodies. वहाँ आपको बिल्कुल क्लियर हो जाएगा. You want me to go into circumpolar body diagram? You see this diagram. This is a rational horizon diagram. मैंने अभी आपके साथ इसे कवर नहीं किया है. So I will be covering it up maybe day after tomorrow. With the September batch I have covered this, so they will be able to understand. But October batch के साथ अभी ये cover नहीं हुआ है. So forget about it. ये जो diagram है इसमें basically एक circumpolar body दिख रही है हमें. You see this star which is there, star X, is a circumpolar body. So circumpolar means it is above our horizon for the full day, 24 hours duration. Now when a body is circumpolar, it comes on our meridian twice. At point B, it is on the observer's meridian. This is the observer's meridian, Papa Z Q S P Z Q S. And when it is on point A, it is on our inferior meridian. Papa Alpha November is our inferior meridian. So this meridian passage at point A, you see here on this side, point A is the meridian passage on the inferior meridian, and it is called as lower Marpas. Okay, beta, did you understand?
Yes, sir.
Okay. The point B, when it is on the observer's meridian, the point B is the meridian passage on the observer's meridian. It is called as upper Marpas. So this is the meaning of upper and lower, which is given in the almanac for the moon. Is it clear, beta?
Yes, sir, all clear. Thank you.
Very good. So we can go back to the longitude correction now. Let me go.
Excuse me, sir.
हाँ बोलो बेटा.
तो ये सर्कमपोलर सितंबर का हो गया क्या हमारे बैच का?
सर्कमपोलर नहीं बेटा, सर्कमपोलर नहीं कराया अभी. PZX ट्रायंगल कराया था मैंने आपको. सर्कमपोलर तो अभी करेंगे हम. We will do, don't worry. Since he had the doubt about upper and lower, that's why I went to that slide. We will be doing circumpolar, don't worry. Okay.
Oh, okay. Thank you.
Okay. So let's proceed now. We know now that the moon phenomena occur about 51 minutes late every day. Now, if the phenomena occurs 51 minutes late, let's now see through a diagram what does it means to us when we are calculating the meridian passage of the moon at any particular longitude. Now let us say we have the moon here at the Greenwich meridian on 7th. We have it on 7th and the time would be 10:43. 10:43 would be the time. Now next day, when the moon comes on our meridian, let me show you here. The moon completes one circle around the earth and comes here on the next day. Next day when the moon comes here, what will be the time, beta?
51 minutes
Sir,
late.
1040 plus 51 minutes.
Right. It is given in the almanac also. It's 11:38 on the next day. So 11:38, the moon is going to be here. Now these are LMT times. Greenwich on the GMT meridian is also its LMT. So moon was on Greenwich on 7th at 10:43 and on 8th it came on Greenwich at 11:38. Now this delay which has happened, has happened over this entire 360 degrees. The moon has turned or moved by 360 degrees. This delay has happened over 360 degrees. Now, if my observer is at a certain longitude, let us say the observer is here, and I want to find out what is the Marpas time for this particular observer, I need to find out or interpolate what is the delay up to here. So how can I find that out? If I get the total delay, that is 11:38 minus 10:43, this is known as daily difference. We call it daily difference. It is the difference in one day between the phenomena of the moon. So this daily difference is occurring over 360 degrees. So using the unitary method for 1 degree, the daily difference would be total dd divided by 360, and for whichever longitude we want to find it, you can find it by multiplying it with that particular longitude. So this is what we call as the longitude correction. Did you understand it from this diagram, beta?
सर एक बार और बता दें.
Okay. Exactly which part, beta, where you are having doubt?
So ये daily difference divided by 360 into.
Okay. अब बेटा कैन यू टेल मी कि ये जो है डिफरेंस इन दोनों में से कितना आ रहा है? 1138 माइनस 1043.
Sir, 55 minutes.
Very good. So 55 minutes. ये जो 55 मिनट्स का डिफरेंस है ये कितनी देर में हुआ है बेटा, और फॉर हाउ मैनी लॉन्जिट्यूड्स? This has covered over 360 degree of longitudes. Moon was on Greenwich meridian. Next day it came back to Greenwich and it was 55 minutes late. So this 55-minute delay has happened for 360 degree motion of the moon. Right, beta?
Yes, sir.
Now let us say our observer is at 90 degree west. I want to find out if the delay for 360 degrees is 55 minutes, what is the delay for 90 degrees? This is what I want to find. How can I find that?
Divide by 6.
For 360 degrees, the delay is 55. For 1 degree, the delay would be 55 divided by 360. For 90, the delay would be this multiplied by 90, correct? Okay, beta, understood?
Yes, sir, understood.
Very good. It is exactly what is given in the formula. Daily difference divided by 360 multiplied by longitude. So this is nothing, basically it is the unitary method of calculation of the difference. Once you get this difference, like in this case it will be
13.75.
okay, so you can call it 13.8 minutes. Now if you want to find the Marpas time here 90 degree west, just add this 13.8 to 1043 and you will get your answer. This is what is longitude correction.
Sir, if you add 1043 and 13.8, we'll get what, sir?
The Marpas at 90 degree west.
सर तो ये करेक्शन एक दिन पहले वाले को लगाएंगे.
जरूरी नहीं है बेटा. अगर आप वेस्टर्ली लॉन्जिट्यूड में हो तो उसी दिन की करेक्शन लगेगी, right? Because this phenomena has occurred before the moon has gone to 90 degree west. Let me show you. Just hold on. how do we apply? Now to apply, first of all, we have to find the daily difference. Okay. Now how do you find the daily difference? There are two options to find the daily difference. Let us say you want to find the meridian passage at a particular location on 8th. Now you can find the daily difference with 7th also. You can find the daily difference with 9th also. So which daily difference would you find? Between 8 and 7 or between 8 and 9? How do we decide this? This is decided basis the longitude of the observer. If the longitude is west, the difference is found between the given date and the next date. If the longitude is east, the difference is found between the given date and one day before or the previous day. Now why is that? You can easily see it here in this diagram. You see we were in westerly longitude here. Now we will find the daily difference on in this we were trying to find it for the 7th. So if we find the daily difference, we will find it between 7th and 8th, because the meridian passage of moon at 90° west will occur after the marpass of moon at Greenwich meridian on 7th, and it will occur before the marpass of moon at Greenwich meridian on 8th. Our occurrence at 90° west will occur between the occurrence at Greenwich on 7th and 8th. Are you able to understand this better?
No, sir.
Okay, I'll repeat once again. Moon जो है, let us assume moon is at this particular location. Right now, it is here. And moon is moving in this particular direction. This is westerly direction in this diagram. This is how the moon moves. Now you tell me कि पहले मून ग्रीनविच पे मेरिडियन पैसेज करेगा या 90° वेस्ट पे करेगा?
ग्रीनविच पे सर.
वेरी गुड. सो सबसे पहली अकरेंस जो होगी वो होगी मेरिडियन पैसेज ऑफ द मून ऑन ग्रीनविच ऑन 7th डे, राइट?
एब्सोल्युटली सर.
इसके बाद बेटा कौन सी अकरेंस होगी? इसके बाद मून पहुंचेगा 90° वेस्ट पे, and we will have the meridian passage of the moon on 7th at 90° west meridian. This will be the second occurrence after that. Correct? Everybody agrees?
Yes sir, I agree.
Yes, sir.
Right. अब 90° वेस्ट पे जब मून का मरपास हो गया, the moon goes further and it comes back on the Greenwich meridian here again. Now when it comes back, it will be the 8th meridian passage. So जो third occurrence होगी वो होगी ये. This will be the third occurrence. This will be the first occurrence and this will be the second occurrence. Up to here, everybody is clear?
Yes, sir.
Yes sir.
So अगर आपको मेरिडियन पैसेज टाइम के लिए इंटरपोलेट करना है for this occurrence at number 2, you will have to interpolate between 1 and 3. So you will be interpolating on the 7th marpass and 8th marpass. Okay बेटा?
Correct है sir. Understood sir.
Right. अब एक और
Because
scenario.
value 2, 1 और 3 के बीच में आ रहा है, इसलिए इंटरपोलेट करना पड़ेगा 1 के लिए.
Yes. जब भी आप इंटरपोलेट करते हो तो आपको एक वैल्यू जो भी आपकी रिक्वायर्ड वैल्यू है उससे पहले लेनी पड़ती है और दूसरी उसके बाद, फिर आप इंटरपोलेट करके अपनी वैल्यू फाइंड आउट करते हो. नाउ लेट अस अज्यूम कि हमारा जो ऑब्जर्वर है, लेट मी चेंज द कलर नाउ, हमारा जो ऑब्जर्वर है ये 90° ईस्ट में है, 90° ईस्ट पे, यहाँ पे है ऑब्जर्वर. दिस इज वेयर द ऑब्जर्वर इज. अब मून जो है ये ऐसे ट्रेवल कर रहा है. द डेट इज 7th. सो अब आप मुझे बताओ कि 7th डे को मून का मेरिडियन पैसेज पहले 90 डिग्री ईस्ट पे होगा या ग्रीनविच पे होगा?
90 ईस्ट।
ऑब्वियसली मून का मरपास जो है वो सबसे पहले 90 डिग्री ईस्ट पे होगा। उसके बाद यू विल हैव द 7th मेरिडियन पैसेज ऑन ग्रीनविच।
यस सर।
राइट। सो अगर हम 8th का मेरिडियन पैसेज लेंगे तो 8th का मेरिडियन पैसेज होगा नंबर 3 पे जाके आफ्टर द 7th मेरिडियन पैसेज। So for 90 degree east occurrence, we cannot interpolate between 7th and 8th because हमारी 90 degree east वाली जो occurrence है ये 7th और 8th at Greenwich इन दोनों के बीच में नहीं हो रही है। हमारी तो 90 degree east की occurrence 7th को Greenwich मरपास से पहले ही हो चुकी। So अगर हमें 90 degree east के लिए interpolate करना है, we will have to pick up the 7th value and एक दिन पहले दैट इज द 6th वैल्यू। हमें 6th को ग्रीनविच पे मून का मेरिडियन पैसेज टाइम निकालना होगा। जो 6th का मरपास है एट ग्रीनविच, इट हैज हैपेंड बिफोर द मरपास एट 90 डिग्री ईस्ट। ओके, सो पहले 6th पे ग्रीनविच पे मेरिडियन पैसेज होगा, फिर 7th को 90 डिग्री ईस्ट पे मेरिडियन पैसेज होगा, and then you will have the 7th meridian passage at Greenwich. So to interpolate for easterly longitudes, you will have to pick up a day before. Did you understand it better?
यस सर, क्योंकि जो टाइमिंग्स है वो हमारे पास ये दी है, मेरिडियन की दी हुई है, जीएमटी वाली,
Right.
ग्रीनिच वाली।
That's right.
सिंस हम ऑलरेडी पास कर चुके हैं तो इसलिए पिछला दिन लेना पड़ेगा।
Exactly बेटा। अगर आप 7th और 8th का टाइम मेरिडियन पैसेज इंटरपोलेशन के लिए लेते हो फॉर ए ईस्टर्ली लॉन्जिट्यूड, तो दैट विल नॉट बी सूटेबल क्योंकि ईस्टर्ली लॉन्जिट्यूड की अक्रेंस तो इन दोनों के पहले ही हो चुकी है। 7th के मरपास के पहले ही अक्रेंस हो चुकी है। सो यू विल फॉर इंटरपोलेशन यू विल हैव टू गो 1 day backwards. If you are in westerly longitudes, then westerly longitude occurrence happens after the Greenwich occurrence. So you will have to take interpolation 1 day later. So let me know your doubts, beta.
सर जैसे क्वेश्चन में 8th में है, 8th को पूछ रहा है, तो हम लोग 7th एंड 8th लेंगे, और वेस्ट में है तो 8th और 9th लेंगे। ये हम द टोटल स्टोरी।
That's right, beta. Exactly, you have understood.
सर समझ में आया सर, बहुत अच्छी तरह सर।
Okay, very good.
तो ऐसे ही याद रख लेते सर, नहीं तो आपने समझा दिया, बहुत अच्छे से समझ में आ गया।
ओके, अब याद रखने के लिए बहुत आसान है बेटा। याद रखने के लिए आप ये याद रखो, दिस इज द फॉर्मूला, longitude correction in minutes is equal to daily difference into longitude divided by 360. This is the formula. You can just take a screenshot or note down this formula. And when you get this correction, if the longitude is east, this has to be subtracted from the time which is given in the almanac. If the longitude is west, it has to be added to the time which is given in the almanac.
सर इसको सर वैसे उससे रिलेट कर सकते हैं अगर करना चाहें। सुब्रा सर के जो अपना थंब रूल है, वेस्ट इज बेस्ट, तो उसमें ऐड भी करना है और आगे वाला भी लेना है। ईस्ट लीस्ट होगा तो पीछे भी वाला लेना है और सब्ट्रैक्ट भी करना है।
Yes, beta, you can connect it with that very much.
सर फॉर्मूला दिखाना सर, फॉर्मूला।
Okay, beta, this is the formula.
ओके सर, हो गया।
Okay, now once you know about this formula, Now you can do the computation of altitude for the moon. So if you go to this chapter, you have this second worked example which is on moon. So you use the exact same method what we have discussed. Okay, see, we started with latitude, did these corrections, we came up to the uncorrected altitude here, entered into the table with approximate mean correction, got the actual mean correction and went back. So just try out this question at home using the method which we discussed, and you should be able to solve it. So practice it at home, and if you get stuck anywhere, let me know in the next session. We will discuss it.
Okay, sir.
Okay. Now we are left with two more topics. One is the computation for Polaris, and next is the computation in any other case. Any other case when it is not Marpas, not Polaris, not moons, Marpas, any other case, how do we solve it? So these two we will be doing in the next class. So that's all for this particular session.